That's not good. Get it to me tomorrow before class. It's half your final grade. I would prefer if you don't print it, I will end up printing it if you send it to me. If you want, I didn't say you had to. Do what? Because you don't have to do those problems. If you did it correctly, you'll get extra points, okay? I felt bad. I had mercy upon you. All right. It is disturbing to me how many classes I have, like, nobody turning in portfolios. Like, if I was any other teacher, that'd be a 0 out of 50. Which means, shut up and listen. Which means that half your final grade would be a 0. Which meant if you got 100 on your final, it'd only be worth 50%. That's awful. That's terrible. So I don't want to stress you out. It's meant to be a good thing because it takes 50% of your grade and guarantees you 50% if you do it well, right? That means if you only get a 25% on your final, you get a 75% on your final, right? Because the 50 was free from the portfolio. But if you don't do the portfolio, you're really screwed, right? And there's no excuse for that. None. So get that to me before class tomorrow. Not during class, not at the beginning of class, but before it. In that bin. Yes. Wonderful. Glad I could. You what?
Wait, hold on.
If you still need time to work on it, then take this time to do so. I assigned it on Monday due today, not tomorrow, because I knew this would happen. I knew it would happen.
You're a smarty pants.
And if I told you it was Tuesday, it would have happened on Tuesday, and you'd really screwed, right? You're welcome. That's right. All right, so, you ready? After doing this packet, probably not in class today because we have to go through it super quickly and we're already really short on time and there's no way we'll get through all of it, right? But after doing this packet, either watching the review from Saturday or showing up to the review on Tuesday or watching that review, whatever you do to study, right? I think you'll feel like if you learned it the first time, and many of you did, actually learn this stuff, not just memorize it. You'll feel like, actually, this isn't that bad. Every geometry class has felt that way, and their stuff is way more difficult, not just because they're geometry, but because it's geometry. Geometry is harder than algebra, right? But also, even the algebra kids that showed up on Saturday felt like it was way easier than they thought it was going to be. Yeah? What? No, it's cool. I don't care. Okay, then grab it.
I got it.
Okay, and then fix it for tomorrow. It's okay. I just want to make sure you have it here before tomorrow, because during tomorrow we're not reviewing. We're going over the portfolios, meaning I'll call you up at my desk, we'll talk about it. The rest of the time will be yours, right? Do what you want. But you need to make sure you have it there, otherwise you're guaranteed to lose 10% of your portfolio grade. Because 10% is the discussion we have for 2 minutes.
I haven't thought about it being something.
Do it. Yeah. So, the idea is I'll call you up and we'll talk about it for about 2 minutes, and I'll talk about your semester so far, see if I can find stuff like that in there. We'll talk about the overall idea. It'll be real short, real sweet. You don't need to plan anything out. I'll just ask you a couple questions. That's it. Right? You shouldn't be stressed about that. It's meant to be another easy 10%. I know. I'm not saying don't stress, because that doesn't help, right? I'm just saying it really isn't something you should be stressed about, and after you do it tomorrow, you'll think that. Right? I know you won't think that before, because that's you, right? But after it, you'll be like, oh yeah, that was no big deal. So try to not be stressed now. I don't know. You're going to be not stressed about it tomorrow after you do it, so why not just pretend you did already? I don't know. Yeah.
Do you have another packet?
Yes, they're back there. All extra copies are back there. Make sure you grab the algebra packet, not the geometry one. Buckets. Here we go. First part of this packet takes forever to get through, and it's a lot of stuff, and it's the stuff you learned a long time ago, and it's when you thought you could BS. Stop. And it's when you thought you could BS this class, so you probably didn't really learn it the first time. So that's going to be the part that's going to be the hardest to get through, and it's going to take the most time. Don't be overwhelmed if we only get through 7 pages or so, and you're like, oh my God, there's still like 30-some, right? The last bit you actually learned, so it's just refreshing your brain, right? This stuff you tried to BS at the beginning of the year, let's be honest, right? You did. And it didn't work out so well. So here we go. Let's talk about the sets of numbers. The smallest of all the sets, the most exclusive of the clubs, is the natural numbers, right? That's the numbers that you would count your sheep with. They're going to be numbers like 1, 2, 3, 4, etc., right? So those are natural numbers. There are very few natural numbers compared to the rest, right? It's very exclusive. Again, it starts at 1, counting up like you'd count if you're in preschool, right? They're natural. Bah. So let's look through here. Any natural numbers that you see? -8, no. This, no, 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 no. Root 4 is actually a natural number because what is the root of 4? 2. That's the only curveball I could throw at you there. So that's our only natural number. Now it is the most exclusive set, meaning that if a number fits into this club, it will fit into all the other ones, won't it? Right? And we'll discuss that as we go. So you can check them. You can just check all the way up if you want. Okay? I'm going to walk through it and kind of teach the idea. So that's the only natural number. Whole numbers. Well, whole numbers are just slightly less exclusive than natural because they also let one other number in. What number? 0. So it's all the numbers that were here plus 0. So here's a 0. So that will be allowed in. And so will this one. Because again, it's all the natural numbers plus 0. So that guy gets in too. The set of integers is twice as lenient as the whole numbers are because they allow all the whole numbers in, 0, 1, 2, 3, 4, 5, 6, but they also allow their negative versions, right? Right now would not be the time to be on your phone if you're learning this for the first time, and almost all of you are because you didn't learn at the beginning of the semester because you chose not to because you thought you could BS this class. So now would be a good time to pay attention. Not that I'm mad at you for being on your phone, I just want to give that last little advice, and then you make your choice, okay? All right, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and their opposites, right? So -1, -2, -3, -4. So going through here, the integers are going to be numbers like -8, right? Because that's a whole number's opposite. So that fits. Same thing with 0, of course, because 0 is a whole number, so it's going to be included in the integers, right? And 2, of course, is an integer. Right? It's whole numbers or their opposites. That's a whole number, so it fits in the integers. Any other numbers that are exclusively integers? Doesn't look like it. Just that -8's a new one to join the crowd. Rational numbers. Now, this is a very big set, almost the largest of all the sets. Rational numbers are numbers that are integers, right? So anything from before, as well as certain types of fractions and decimals, okay? So here's 2 ways to think of it. One is that rational numbers terminate or repeat. Either or works. Repeat means there's a pattern. Doesn't mean it goes on forever. Lots of numbers go on forever. But if it goes on with a pattern, then it's a rational number. If it terminates, meaning it stops, it's also that. So first of all, -8, does it terminate or repeat? It terminates. It stops, right? There it is, -8, done, right? Does 0.219 terminate?
Yes.
It does not terminate, it goes on forever, but it does have a pattern, so that means it repeats. Does that make sense? See how it has a pattern to it? Okay. Pi, does it terminate? No. Does it repeat? No, it has no pattern to it. It is irrational, so it's all the way down here. Remember, if you're not rational, you're irrational. 0, does it terminate or repeat? Yeah, it terminates, right? Stops right there. -1/3. Well, that's really -0.3 repeating. So that repeats, which means it has a pattern, which means it's rational. Are you smelling what I'm stepping in?
Yeah.
-0.991. Doesn't repeat, doesn't go on forever, but it does terminate, right? It stops right there. So that's a rational number. That's it, right? It stops. It stops right there. 2, does it terminate or repeat? It terminates, right? Stops right there. So that's rational. See how rational includes almost everything? It's a very big set. It lets almost everybody in. √2/2. Now this is a tough one. If you were to type that in a calculator, it would go on forever with no pattern, which means it doesn't repeat and it doesn't terminate, which means it is irrational. Now, you might think, how would I have known that, right? Well, there's another way to think about rational numbers. So I'm going to talk to you about it in a second. There's one way, right? That works, right? If you convert this stuff to decimals. But there's another way to think of it. A number is rational if it has these 2 things, okay? So if a number can be written as P/Q, where P exists in set Z and Q exists in set Z. So if A is that, then A exists in the rational set. Okay, words are hard, math is easy. Let me explain what this means. So say you have a number. If you can write it as a fraction where the top number and the bottom number are integers, then it must be rational. So for example, -1/3. That's a fraction, right? The top number is -1. Is -1 an integer? Yeah, right? Integers are the negative and positive whole numbers, right? So that's an integer, so P exists in Z. Does the bottom number, is that an integer? Look at 3. Is 3 an integer? Yes, 3 is an integer, right? It's the positive and negative whole numbers, right? So the top is an integer, the bottom is an integer, which means this is rational. So if a number can be written as two rational numbers over each other, then it's, two integers over each other, then it's rational. So if top is an integer, bottom is an integer, then the whole thing is rational. -8. It's rational because you can write it as an integer over an integer, right? -8/1. They're both integers, top and bottom, right? 0 is rational because you can write it as this, right? Rational or integer on top, integer on bottom. How would I write this as an integer on top and an integer on bottom? Right? If I divide by 10, it moves the decimal place over. So if I divide by 10,000, it moves it over a bunch. Right? That works. Look at pi. You might think, oh, I can write pi as a fraction, and you'd be right. But can you write it as a fraction where the top and bottom are integers? No. Is pi an integer? No, right? So that doesn't count. That's why it's irrational. Another way, √2/2. Bottom number's an integer, right? Is the top number an integer? No. Mm-mm. And it doesn't simplify to 1, does it? If it was √4/2, well, I could make that √4/2, right? And that would be a rational number. But √2 is not an integer. Bottom is, but the top isn't, so it's irrational. How do you feel about that last idea? I feel like this is the hardest set to understand, and then integers right after it. Integers, positive and negative whole numbers. You know what I mean by that?
Yes.
Okay. Rational number terminates or repeats. Another way to think of it, top and bottom are both integers. Okay? Top and bottom are both integers. How do you feel about this chart so far? Last bit is the easiest, the real numbers. Real numbers includes everything. It lets everybody in. We're going to learn about non-real numbers, imaginary numbers next semester, but right now we don't know about any. So all of these are allowed in. Now you can kind of see which sets are the biggest, right? Real is the biggest set. It includes everything, right? Next biggest is rational. Next biggest is integer. Even smaller is whole numbers. The most exclusive of the set is natural numbers, right? Actually, the second biggest set would be irrational. Almost all numbers are irrational. It's crazy. Just as true. If you were to imagine a dartboard with all the numbers and you threw a dart, odds are you would hit an irrational number more than anything else. Just how math works. To hit a natural number would be crazy rare. To hit 3 on the dot or 4 on the dot or anything like that, right? That'd be super rare. Turns out, to the power of infinity, every number is just as rare to hit as any other number. But also when you throw the dart, you're guaranteed to hit the dartboard, which means you're guaranteed to hit a number, even though it's infinitely impossible to hit one. Yep.
Well, it's not always the answer.
Infinitely impossible to hit a specific one, but infinitely likely that you will hit one.
You couldn't miss the
Right.
board.
True, that's true. And then you'd end up in different number land. There's more numbers than just real and irrational.
There's
Imaginary, there's even more than that. It's crazy.
We have to learn that next year.
You'll learn it eventually. All right, so how do we feel about the chart? Again, I said the beginning takes the longest to get through. Don't be intimidated. We've only gotten through half a page. We're not going to get through much today.
Pretty decent.
Let's look at number 10, 11, and 12. Again, you didn't learn this originally because you thought you could BS your way through this class.
Yeah.
So I'm going to teach it for the first time, which is why it's going to take more time. Yes.
Is our testing Wednesday or Thursday?
You are odd, which means Wednesday. Okay? Good idea.
Oh, wait, another question.
Yes.
Well, it says like just like no when you're walking around.
Mm-hmm. Everything will be normal. No calculators. I'll walk around. Yeah, why not?
That's good.
Right? I mean, I don't ever give you answers or cheat for you.
No, but
You're just like, why is my work wrong? And I'll go, hey, 2 times 4 isn't 6, Chief. Right? Yeah.
Be something I do.
Oh, okay, okay. Yes?
Yeah.
No. Are my quizzes or tests ever as long as the review packet? No, I just like to give you lots of examples, and then I cut out the questions I don't want. Now, do you need to understand all of this? Yes. I guarantee, even if I don't ask you specifically, what is 6 to the negative second power, you'll probably have to know that somewhere in another problem, right? Yes, right? I mean, like, it's going to show up. The question is, will it show up alone? Probably not. It'll probably be part of another problem, right? Okay. So let's talk about what these things mean. So, again, it's going to take a while to teach this, which is why we're not going to get through much today, because you guys didn't really learn this the first part. You were trying to BS your way through it, okay? It happens every year. It's okay. I know. I warn you, but no one listens. I wouldn't either. Right? I'd try to BS my way through it as well. So, let's talk about what squaring a number means. 2 squared. That means 2 times itself, right? So we're going to do 2 times 2. That's what you were told a long time ago, right? And that's mostly true. And that gets you 4. 2 cubed, then, would be 2 times itself 3 times, right? Which is 8. And 2 to the 4th would be 2 times 2 times 2 times 2, which is 16. 8, because we got 2 times 2 times 2. That's 2 cubed, right? Times 2, which is 16. Great. 2 to the 1st. Now we're working backwards. Instead of adding on a 2 each time, we're taking a 2 away. So it's just 2. Kind of weird, but it works, right? We're taking a 2 away. What's 2 to the 0th?
1.
I have people saying 1. Can't be just 2. 2 to the 1st was 2. I have some people saying 0. A common answer is 0. A common answer is 1. The reason it is 1 is because you didn't know the full story. 2 squared is not 2 times itself. It's actually 1 times 2 twice. 2 cubed is 1 times 2 3 times. 2 to the 4th is 1 times 2 to 4 times. And the reason they didn't show you is obviously it doesn't change the answer, right? They're like, why teach them that? Well, here's the problem. Then you get to math in high school where you're starting to go this way, and you need that 1 for it to make sense. 1 times 2. Now we're removing a 2 each time. Now there's no more 2's. Do you see how it's 1? That's why 2 to the 0th is 1. Anything to the 0th is 1. What's 2 to the negative 1st then, using that logic?
1 divided by 2.
I don't want the answer, because I know the answer. It's a half. Can somebody explain why it's a half? You were there, right? Were you there on Saturday? Yeah, so you know. Anybody that wasn't here on Saturday that knows why?
We know divide by those.
So check it out. When we're removing a 2 each time, how do you remove times 2? You divide. So I divided by 2 to move down, right? So now I've got 1 divided by 2, right? Because there's no 2 to divide out. What's 1 divided by 2? A half.
I only know this because I watched like 90% of the review stream while I was listening to it.
That's a half. Otherwise known as the reciprocal. Up here, 2 to the 1st was 2. 2 to the negative 1st is the reciprocal of that answer. See how they go together? Right? So a negative sign really means reciprocated. Right? That's kind of the shortcut. 2 to the negative 2nd? Well, it's going to be 1 divided by 2 twice, right? So it's going to be 1 divided by 2 twice.
No divisional quantity.
Which, of course, is going to equal 1 over 4. And notice how that's the reciprocal of 4. 2 to the positive 2nd, 4. 2 to the negative 2nd, 1/4. Feeling better? 2 to the negative 3rd. That's going to be 1 divided by 2 3 times. 1/8. The reciprocal of 8. Do you see how that works? So what it does is it reciprocates it, right? 2 cubed on the bottom, because it's been reciprocated, which is 1 over 8. How do we feel about those? Better now? Jordan, you with me? Okay. So now let's answer some questions. Let's look at number 11 first. 6 to the negative 2nd. Well, that's going to be 1 divided by 6 twice. Right? Because that's what that means, 6 squared. Which means it's 1 over 36.
Yes.
Right?
6 squared is 36, reciprocate it 1 over 36. Same thing, right? This one. Remember PEMDAS, it's sort of true, sort of, kind of. What comes first? Multiplication or exponents? Exponents. That negative sign there means we're not going to multiply by 1 like we have here, right? It means we're going to multiply by -1. So really what that means is -1, and then 6 squared is times 6 twice, right? So what's that answer? What's this? 6 times 6 times -1. -36. So we do the exponent first, 6 squared, and then we negate it. -36. Okay?
Yeah.
Jordan, was that okay? Okay. This one down here. First off, it's in parentheses. See how that's different than this one? Which means we're going to do the multiplication part first. So we're going to do -1 times 6 first. Then we're going to negate that with a negative exponent. So that's going to be -1 times 6, which is -6, right? And then we're going to times it by itself twice. What's -6 times -6? Positive 36. Negative means reciprocate it. So that's this. -1 times 6 is -6. We're squaring that. So we're going to divide by -6 twice because it's -2. That's 1 over 36. Another way to think about it is that, look, that's -6 squared. The negative is included with the number, right? What's -6 times -6? 36, then reciprocate it. This one was 6 squared, which is 36, and then you negate it, right? The square happens first. The negative happens first because it's in parentheses. Parentheses come before exponents. How do you feel about that? That one's weird. Are you feeling sort of okay with that? Sort of? Negative goes with the number. So when we square it, it's -6 squared, which is 36. Negated means flip it. Okay? Here, -6, the negative doesn't go with the number. That comes later. We do 6 squared first, which is 36, and then negate it. Okay? Parentheses means first, so -6. If you were to type this into a calculator, you would get -36. And you'd be like, what the heck? -6 times -6 is 36. If you wrap it in parentheses, though, then you get the right answer. The calculator knows you do the square first, then negate. This one, you do the negation first, then the square. And then flip it because it's -2. No yawning in math class. Page 2 of your hymnal. Circle each term. Here we go. What is a term? Yeah, anything separated by a plus or minus. What are you saying? Yeah, I know, she thick, right? I know. So anything separated by a plus or minus is a term. So there's a term, there's a term, there's a term, there's another one, and another one, and another one, and another one. All those are terms, anything separated by a plus or minus. Notice that 2 and x squared aren't separate terms because they're not separated by a plus or a minus here. Yes? Oh, please. How many do I have? A finite amount. And if all of you want them, you're going to have to fight for them to the death. Remember that scene where the Joker breaks the pool stick? Yeah, I'm going to do that with these guys. What? Anyway. So bring your own. That's what I would do. Okay? So those are all terms. They're separated by plus or minus. Notice that 3 and x squared aren't separate terms because they're separated by no plus or minus, right? It's multiplication. Then it says underline each coefficient. A coefficient is a number in front of an exponent. So 3 is a coefficient. 6 is a coefficient. 2 is a coefficient. Now technically there's a 1 in front of that x, right? So that's a coefficient as well. I'm not going to underline that because they didn't bother writing it, so I'm not going to bother highlighting it, okay? Also technically, fun fact, -8 is a coefficient. It is. You're like, wait, there's no exponent there. I'm not going to underline it because this is like meta, like 200 IQ level, okay? Isn't it x to the 0th power next to it? Anything to the 0th power is 1, so it's just negative 8. So technically negative 8 is also coefficient. But we're not going to underline it, just like we wouldn't underline the 1 in front of the x. Yeah. Yeah, what? Nah, you don't have to underline it. Now it says combine like terms. Like terms have the same exponents for their variables. So, tell me which terms I can combine. List me some. Xian, tell me which ones I can combine. X2, you mean x squared? Okay, and what else?
3x squared.
Negative 3x squared and 2x squared. So we combine all our x squareds. We have x squared plus 2x squared, which is 3x squareds. X squared plus 2x squared is 3x squareds, and then we subtract 3x squareds to get 0x squareds. That means it just goes away, right? Nothing left over. Normally I wouldn't even write that because it goes away, right? 0 times anything is 0, right? Then I've got what else that can be combined? Negative 8 and positive 11 because they have the same coefficient, or the same exponent, x to the 0th power. Or they're just constants. That's what we think of them as, regular numbers. So that's 3. What else can I combine? Get our x's together. Terrible idea in real life, great idea in math. Negative 6x plus an x is negative 5x. So since that goes away, we just have 3 minus 5x. That's as simple as it gets. Could you take x and square it, subtract 8, subtract 6 times x, do all that? Yes, you could. Or you could just do that and you get you the same result, right? That's why we call it simpler. It's less steps, less things to do with x, but it gets you the same result. How do you feel about that? Terms are anything separated by a plus or minus. Coefficients and the number in front of exponents, or in front of variables. Combining like terms, I feel like we should all know that by now. All right? And if you don't, come talk to me, I can help. 14. Oh, God, here we go. Buckle up. It's not that bad. We have, think of it as terms. This right here is one idea because it's in parentheses. Then that's going to be divided by another term. And see how minus 1 is a separate term from 5 times 2 because it's separated by a plus or minus? That's a different term. And then we have another term back here, which is one idea, right? Because it's all in parentheses. Within that term, we're going to have another term. We got termception here. And that's going to be an idea as well. So when I write this, it's negative 5 plus 5. What's 5 plus 5? 10. And then we're supposed to divide that. Always turn those into bars, right? What's 5 times 2? 10. Now that's a separate thing. So the minus 1's not going to go under here, right? It's going to be a separate thing. It's going to be minus 1 over this idea, the red term, which is 2 minus 3 over 3. Let me walk you through it. What? You could, but I'm showing all my work. So here's the idea. We have this term divided by this term. Then we're subtracting 1 divided by this term. And this guy's included. Because it's all in parentheses, it goes underneath. Don't lose your focus. It's all in parentheses, so it all goes underneath. Cool? Now let's simplify. What's negative 10 divided by 10? Minus 1 over, what's 2 minus 1, 3 over 3? Well, 3 over 3 is 1. So 2 minus 1 is 1. So we have negative 1 minus 1, which is negative 2. Again, break it up into terms. Parentheses, make it one term, right? It's saying this is one idea. And then solve. Always turn division signs into bars. Ready for 15? We have two terms here, two big terms, right? This guy is all one idea, and this guy is all one idea. Within there are smaller terms, right? I'm not going to highlight all those because I think you can see them. This guy is his own term as well. It is. We have big idea, and then we have smaller ideas throughout. Again, this is a small idea. This is a small idea, etc., right? I said I wouldn't do it, but now I'm doing it. Maroon, mauve, chartreuse, burgundy. These are all their own ideas. They're all their own terms. Right? So let's take this idea all together. Here we go. What is negative 3 squared? Again, the negative's not in parentheses. We do the square first. What's 3 squared? And then we negate it. Negative 9. Negative 9 is just negative 9. Then we have plus a negative 3 in parentheses squared. So what's negative 3, the quantity of negative 3 squared? That's going to be positive 9, right? We apply the negative first, so it's negative 3, and we're squaring it. Negative 3 times negative 3 is 9. So we're adding 9 there. And then we have regular 3 squared, which is 9. So altogether we have 9, 9, 9, 9. You have a question about that? The joke? Oh, the joke is what you don't get. It's a movie by Quentin Tarantino. Nice. What's 2 times 3? And then we're going to add 5. And then we're going to subtract 6 times 2 over 1. Well, when we subtract 6 times 2 over 1, we're subtracting 6 times 2 over 1. Well, what is 2 over 1? It's its own idea. Oh, I'm sorry, not 2 over 1. 2 to the negative first. What's 2 to the negative first? 2 to the negative first is 1 over 2, right? 2 to the first power is reciprocated. Now let's do math. Negative 9, positive 9, positive 9. 0. Now, if you're smart, you'll realize 0 times anything is 0, so we don't need to do any more work, but I'm going to show you how stuff works. 6 and 5 makes what? And then we're going to subtract 6 times a half. Well, that's 6 divided by 2, which is 3, times 1, which is 3. So we get 11 minus 3, which is 8. And 0 times 8 is 0. It is if you know what you're doing. If you don't know what you're doing, it's impossible, right? Okay, how do we feel about page 2? Okay. Rearrange each equation to solve for the variable. Get x on its own, get y on its own. How do we feel about that stuff? Okay. How do you feel about 17? Yes. Times by 9, divide by y to get x on its own. Times by 9, divide by x to get y on its own. Divide by 2 to get p on its own. That one's the weird one, I think. Notice that xy divided by 9 is already being divided by 9, right? And so when we divide it by 2 to get rid of that p, we put it on the bottom, because that's what division is, right? And we get xy over 18 equals p. Another way to think about that is if you already have something divided by 9, and then you divide it by 2, haven't you really divided it up by 18? Right? That's the idea. Dividing by 2 is just multiplying by 2 on the bottom. Remember, division is just multiplication done on the bottom. Chicka wow wow. 18, add x and add y to get p on its own. Add y and subtract p to get x on its own, then negate it. So to get x on its own, I would do this. Subtract p, add y. And then when I negate something, I'm dividing by a negative or multiplying by a negative, your choice, right? And that's just going to negate everything. Negate means what? Change the signs, right? So if I change this guy's sign, I have to change this one. And this one. And this one. So that's x. I'm not going to do the rest. Feel good about that? Okay, number 19. This one seemed to confuse a lot of people. Imagine the problem was this. How would you solve it? You times by 2, right? So instead of timesing by 2, what are we going to do to solve this? Times by the quantity of x minus y. There's two ideas there, right? So they have to be wrapped together if we're going to multiply by both, right? So we have to put them in parentheses. So we're going to do this times the quantity of x minus y is p. Done. That's p. Now to solve for x and y, I'm going to start from here because I know that if I divide by 5, I'm here. Right? And then I can add y to both sides, and I get this. Or I can subtract x, and I get this. This one's done. And then how do I get rid of that negative in front of the y? Divide by -1, times by -1, negate it, right? Which means change the signs. How you like them apples? Feeling good about that? All right. Are you starting to feel better as we get further away from the beginning of the year? No? Who said no? It's okay. We're not away from the beginning of the year yet. We're still kind of there. All of these are just more practice. Times by 5, subtract 3x, y is on its own. Times by 5, subtract y, divide by 3, x is on its own. Divide by 2. When we divide by 2, what's the denominator going to be? When we divide this by 2, what's the denominator going to be over here? 10. Very good. Let's move on. Oh, squares right here. Save that for last, right? Root everything when you're done. Otherwise, leave it alone. Skip to page 7. Let's look at 30. This is just multiplication, right? How do we multiply fractions? Do we need common denominators? No, we just do what it says. It says times 3 and divide by 4. Which one do you want to do first? Let's do 24 divided by 4 and get what? 6. So we have 3 times 6, 18. This one, times by the top or divide by the bottom first. What do you want to do? Times by the top. What's 2 times 12? Good, and then we're supposed to divide that by 3, which is going to be? Close, 8. Could you have done 12 divided by 3 and got 4? And then times by 2? Yep. Probably safer that way, right? We like division when it works because it makes the number smaller, and we like small numbers. When it doesn't work, just times by the top first. This one, you want to times by the top or divide by the bottom? Let's divide by the bottom to make it smaller, right? You could do 3 times 28 in your head, and then divide by 14, and hopefully you know what that is. I'd rather divide first and get 2, and then times it by 3 and get 6. And you look like a genius. 3/14 of 28, right? 6. It's insane. But you know, divide by 14 times 3. This one, oh God. Well, can't we divide by 15 by 3? Yeah, so that's 12 over 5 times 5. What's 5 divided by 5? 5 divided by, I did 15 divided by 3 and got 5. What's 5 divided by 5? Times 12 is 12. $15 divided by 5. That's fine. You could definitely do that. Don't cross multiply. But yes, 15 divided by 5, and then 12 divided by 3. That works. And then you multiply them. That's fine. You'll need that for this example. Everybody look at 37. Page 8. As is, you can't divide any of these. 24 over 9 does simplify, but we're not going to worry about that. Pretend you don't know it. What if it, we can do it in any order we want. Let's do 24 divided by 4. What's that? 6. So we have 15 times 6 over 9, right? 24 divided by 4 is 6. We still have to divide it by 9. What do you want to do? 15 times 6 or 15 divided by 9 first? 15 times 6? What's 15 times 6? 90, which is 10. Another way you could have done it. Couldn't we have done... we could have rewrote this as 15 over 9 and times 24 over 4, right? Because it doesn't matter what order we do it in. And now you might be able to reduce this and say that's 6 times 15 over 9. And 15 over 9 reduces to 5/3. What's 6 divided by 3? Times 10? Or times 5 is 10, right? Either way. Whatever works for you. Just make sure you do it all, right? 38. Yes, we did. 5x minus 14 greater than 6. We need to graph it, find the solution set, etc. Remember, we treat it just like an equal sign, except when we divide or multiply by a negative, what do we have to remember to do? Flip the sign. So what am I going to do to solve this? Add 14 and divide by 5, right? When I do that, did I divide or multiply by a negative? No, so I don't have to flip the sign. Adding 14 gets me 20. Dividing by 5 gets me 4. So graphing it, only one variable, so we only need one axis. So I'm just going to graph it like this. Here's 4. Open or close circle. Open, because it doesn't include 4, but is anything greater than it. So x is anything over here, right? Where we color is where x is. And then it goes up to, but not including 4, right? It stops right there, and then we leave this blank as well. Remember, blank is where it isn't. That's why that's open. Okay? How do we write this as a set notation? Well, we say x exists in the real numbers. Oh, whoops. And it has to be between here and here. Ignore that. Ta-da! X is any number. Now, if it was a word problem, maybe it couldn't be any number. Maybe it had to be just whole numbers, right? Can't have a half a student, for instance. At least you wouldn't want to. I don't want to. Terribly messy. Yes? Yes, that's the set notation. You could also write it like this, because that implies x can be any number, which is a real number, right? Maybe it'll say in another problem that it has to be integers only, and so you'd write it like this, set z, right? Maybe it'll say it has to be just whole numbers, because we're talking about students. So that's set n sub 0, right? That's a good looking one. I don't know, it just is. It was funny, right?
Yeah.
All right, what about 39? What do I need to remember to do for this one? Because I'm going to divide by a negative number, which means this. Good. If you don't flip the sign, it won't make sense. 0 is greater than negative 3, right? But if I plug in 0 here, if I didn't flip the sign, then it wouldn't make sense. I'd get 0 less than 9, which is true. But here, if I didn't flip, I'd get 0 is less than negative 3, which isn't true, right? So make sure you flip it. Otherwise, it'll be changing the problem. More of the same here, more practice. Flip to page 11, number 44. Now we've just got two at once going on here. So we just take them separately, right? It's an OR problem. So what am I going to do to get x on its own? I'm going to add 10 and divide by 12. Do I need to flip the sign? Nope, because I didn't divide by a negative or multiply by a negative. So I add 10 and get 72, divide by 12, and I get 6. Yep. Over here, I'm going to subtract 5. Do I need to flip the sign? No, I'm just subtracting by 5. Not yet. Now I'm here. Now I'm going to divide by negative 9. What do I have to do? Flip the sign, and I get 2. X is any number as long as it's greater than 6 or less than or equal to 2. Here's the graph. Hopefully I see you guys tomorrow. I don't know, a lot. Pass it. Yo. Mm-hmm.
So I put like page 7 here. And then
Rad. You didn't have to do that. That's good. Yeah.
And I put page 7A right there since it's just the same thing. Okay.
Rock on.
That's good.
Goodbye.
Me and Troy.
Tomorrow your review is from 3 to 6. Be there or don't. It's up to you.
Yeah.
Yep. 3 to 6 tomorrow.
Yeah, that's why I'm asking.
Okay, go grab it.
I'm
Start right now.
for the last half an hour.
Yeah, just
Whatever you want to do. I'll stay late if you need me to. I will.
Yes, please, because I've practiced after school, so
Cool.
I'm gonna miss both of it.
Yeah, whatever you need to do, we'll make it happen, okay? Show up or don't. Show up late, leave early. Show up in the middle.
If you're willing to
Leave halfway through, come back. I don't care.
If you're willing to be after school, then
Yeah.
I'll turn my phone.
Whatever you need, I'm willing to make it happen.
Okay.
I'm gonna go home and get it. Like,
Good. Turn it in tomorrow morning or come back. I don't care. I'm here until 9. Yep. Geometry review today. No, you don't. I challenge them. Just differently. You don't want to be in basic geometry. You're much better at regular geometry. Basic geometry, you kick your butt.